I'm going to just quickly talk about the VMware Secure Access. This is the first service, SASE service that we actually launched in our POPs, right? When we talk about Secure Access purely is for bringing in remote users into the enterprise network to access like enterprise private applications, right? So let's first talk about the end-to-end zero trust security, because some of the concepts of the secure access fall into the zero trust security part, right? What we did with secure access is we bought two industry-leading components together, and we offer it as a service. So most of them might be familiar with VMware Workspace ONE. It's actually VMware Workspace ONE is a leading endpoint unified compute product, and it has a lot of endpoint end device security related features and stuff, right? So one of the just to give you an idea, with Workspace ONE, it's actually a product where it brings an MDM and then a per application based VPN into perspective, right? So the MDM is to actually protect the device itself, right? Obviously protecting the device in the sense what kind of data comes into the enterprise and stuff. And then also goes into the concept of zero trust network, which is, hey, first I authenticate the user from like a proxy, which is sitting in our SASE POPs. And then once the user is authenticated, then based on the policy, I'm going to let the user access the applications based on the policy that is defined, right? Forming this basis, what we have done is with additional components with Workspace ONE, for example, we have the Workspace ONE Intelligence, and we have Workspace ONE Access. So what we do is we can actually bring in additional context when giving access to those applications. Hey, is the device compliant or not, right? If the device is compliant, I'm going to actually have this user access to the certain applications, or I'll let the user do certain things with the applications, right? And then you can go beyond that. Hey, how is the user accessing the internet, right? So the solution itself can look at the traffic that is being actually accessed by the user on different set of devices, and then a risk score can be correlated based on the access, saying that, hey, is the user actually too risky in terms of the destinations that he's going to, right? If he's classified as like a very risky user, can I actually send him through more set of security services and stuff in order to actually make the inspection, make the security more stricter, right? So that's the whole emphasis of the secure access, right? How we actually get more and more context about the user, and then we can apply like the other services that Craig talked about in the SASE POP itself, in order to be more granular, and also in order to have more flexibility in terms of when do we need to allow the users to access the application, and how much of access do they have for a particular application and stuff.
Is there a differentiation with applications between corporate versus personal use? So if I'm logging into Dropbox, is there a way to tell that I'm using our enterprise Dropbox account or a personal Dropbox account?
So when the traffic is brought to the SASE POPs, we have the Cloud Web Security Service, which actually, when we send the traffic through the Cloud Web Security Service, that will have a CASB functionality where it discovers applications, and then the applications can be marked saying that, hey, whether it's actually a sanctioned or unsanctioned, to your point, whether you have an enterprise application which is boxed, once it's discovered, the policy can be set up saying that there's actually a sanctioned app by the enterprise admin in order to actually make those kind of decisions.
Yeah, so at that level, you're approving that app, but you're not necessarily approving personal use versus corporate use.
Yeah. So there are actually further controls that can be done, saying that, hey, for because the security is in line. So there are further controls saying that, hey, I want the users to have full access to, let's say, for example, the sanctioned apps. They can upload, download, right? For unsanctioned apps, like any personal apps that are categorized as unsanctioned, there are actually controls saying that, hey, don't want them to upload anything. They can just download and then view. We are also bringing DLP with CASP, where with DLP, you can actually look at certain patterns, and then you can control saying that, hey, if you find a particular file which matches a pattern where some data is classified and the user is trying to upload it, then actually block that upload as well. So there will be a lot of functionalities which will be supported in order to like classify what type of data and then what type of actions that can be done.
DLP was my next question. Thank you.
Yeah, sure. Since the basis was remote access, when we talk about remote access, so today when we look at like how some of the enterprises do remote access, what they have is like a VPN gateway, which is sitting at like probably at if they have single data center, they may actually backhaul all the users to a single data center using to that VPN gateway. The mobile users may have like a client where they form like an IPsec VPN to the gateway, and then they bring all the traffic to the VPN gateway, have it inspected by a centralized firewall, and then send it off to the internet, right? So when Craig talked about like how the trends are changing today, where the applications are getting diverse, or when the applications are getting distributed, to be more specific, right? Going away from the data center. So backhauling and then bringing all the traffic to the data center doesn't actually give a good experience for users. They need to actually go to the nearest locations, nearest front door locations for the application access. So the backhauling is actually not a very good idea for user experience, right? And then the other point also is when there is a uptake in like demand, when you need to actually scale up or scale down, right? So having this physically located VPN gateways, it becomes actually really difficult to instantly scale up and scale down, right? In order to address these, what we have done with VMware Secure Access is we offer this as a service to our customers. So Craig kind of talked about like how our gateways are globally located at different locations, right? So whenever a user needs to connect to any enterprise private application, like for example, if it's actually a public cloud hosted application, right? Then we could bring the user to the nearest POP, tunnel the user traffic to the nearest POP, and then actually hand it off to the nearest front door of the public cloud company itself or the vendor itself, right? So there is no need to actually bring the user all the way or backhaul the user all the way to the nearest data center, enterprise data center, and then send it off to the internet. And the other point is also I talked about scaling up and scaling down. So Craig kind of went through the POP architecture, where we are actually evolving our POP by bringing in, by making the infrastructure more conducive to run like cloud native applications and stuff. So the secure access is going to be our first application, which will be run in a cloud native mode. And the advantage of that is, hey, depending on the user traffic, so depending on the number of users, like for example, an enterprise has a conference or something in a particular location, and all of a sudden they have like 10,000, 20,000 users actually connecting to their applications from a single location, right? So there is the infrastructure enables the service to actually automatically scale up and down based on the demand, right? That's the advantage that the customer gets when it's actually when we offer it as a service, and then obviously when we run it on a cloud native based infrastructure, right? The other aspect is, I guess, with SD-WAN itself. So we have a protocol, or we have our own secret sauce called dynamic multipath optimization. So when the traffic has to go from the POP to the data center, right? If there is an application which is hosted in the data center, then the user experience can be enhanced because the DMPO, like between the POP and then the data center edge, so it will work on figuring out, hey, what is the path with like least latency, jitter, and packet loss, right? Enhancing the user experience. So these are all the advantages that the VMware Secure Access brings in as compared to like the traditional remote access technologies. Just to kind of actually summarize, right? We focused on the zero trust component where it forms like a per application based VPNs, right? And also there is an option of MDM, right? So the enterprise can choose to say that, hey, there are actually certain devices where I want more control on the devices, like what are the applications being installed and stuff in order to secure. So in Craig's slide, if you remember, I guess it was like, I don't exactly remember the number, 90% or 65% of the attacks came from the endpoint, right? So in order to kind of secure that endpoint, there is like MDM functionality available, along with like, obviously VMware has Carbon Black to run advanced endpoint security protection. And then it's offered as a service, so the customer really doesn't have to worry about, hey, I mean, how it's deployed, or do I need to actually operate it and manage it? And the other thing is a better user experience with our DMPO, and then also with not backhauling all the way to the data center and stuff. So these are the kind of advantages that the enterprises get when we combine the Workspace ONE capabilities with our like gateway with our POP and then SD-WAN product. I kind of talked about the secure access advantages and stuff. So I did mention that this is going to be like going to be the first service where we're going to run as a cloud native. So I wanted to kind of give a little more internal details on like how we are doing it, right? The architecture that we are focusing with secure access is obviously by running containers and stuff, it becomes more, it becomes actually more optimized for us, like how we use our resources. And then also we do support multi-tenancy on our SD-WAN, and then we want to actually take the same concept because we want to actually bring multiple tenants into the POP, right? There will be like multiple customers coming into the POP, right? So we took those components, and then the other one is, hey, we need flexibility to say that, like, for example, in the first slide when I talked about when we have more context, right? So how are we going to exchange that context as a metadata when it goes to the other service so that the other service understands what I need to do with it, right? Or even the service which actually, or even like a service which sends the data off to the next service, right? For it to understand, hey, I received this particular session or a packet. Now I need to, so that it can look at the metadata and then say that, hey, this user session was actually classified as like a high risky user. So I need to actually, I need to make the next service understand, saying that it needs to run more thorough security capabilities, security services and stuff, right? So that's where the Geneve tunnel comes in. So the idea with Geneve tunnel is we can pass this metadata saying that, hey, whenever the context changes, like the multiple contexts that we have of the device or the users, whenever the context changes, so we pass this in the Geneve metadata so that the following services and stuff, they understand what needs to be done with the data, right? So just to kind of do a packet walk, what we have today, for example, on the left side, you have a user which forms like a TLS tunnel to a load balancer, which is actually located in the front. So what the load balancer does is it's actually a tenancy-aware load balancer. It looks at the SNI which is coming in, the TLS SNI, and then it actually load balances that particular tenant traffic to a bunch of Kubernetes pods, right? So the whole idea is, hey, I want to actually make sure that the pods which are actually spun up for that particular tenant, they are the ones who are actually servicing the traffic and stuff, right? So once it comes into the secure access containers, so obviously the secure access does all the policies which are configured, and if there is a policy on the VCO becomes like a Uber orchestrator, the Velo Cloud orchestrator. So depending on the policy which is configured, the container itself will add a Geneve header to it, depending on what it receives from. Craig talked about GSM, right? Depending on what it receives from GSM, it will add a VNI header or a Geneve VNI header. Geneve header with VNI, sorry, and it will actually send that to the next service so that the next service understands, hey, this is coming, for example, this is coming for this VNI is associated for this tenancy, right? So it goes to the gateway. The gateway is like a central point from secure access. It goes to the gateway. The gateway, based on the Geneve header VNI information, it looks at the tenancy, and then it actually looks at the destination IP, and then it figures out, hey, do I need to actually send this to the internet, or do I need to actually send this to the internal, like a data center or something like that? If it needs to go to the internet, then it will actually go to the Cloud Web Security Service. The Cloud Web Security Service, again, looks at the VNI and the Geneve header, figures out, hey, which tenant it belongs to, what kind of policies it needs to apply, and then it actually sends it off to the internet, right? So that is the kind of the packet flow inside our SASE service. And then like Craig mentioned, right? So we are planning to make the POPs as flexible as possible, because like we plan to run like other services on the POP. It could be cloud native, it could be like a VM-based service, it could be a VM-based service. And then we are planning to see how we can interact between like different types of services, and then how we can exchange metadata, and then how we can have a common policy framework across all the services and stuff. So that's essentially the kind of evolution of our POPs, the way we are looking at right now. Any questions?
Yeah, Vinod, so I saw in there, Workspace ONE and Carbon Black, and I understand those are obviously VMware products that that have been picked up. But what if a company already has a competing product in those spaces?
So what we do is today, like shortly, we're going to support just an unmanaged client with just only a VPN, where you can run your own MDM, or you can run your own endpoint security product. And then we can still bring the traffic just by VPN, just with the TLS VPN to the SASE POP, and then apply these services. When you talk about like how the data and then the context are exchanged, then there are like APIs on like Workspace ONE Access, Workspace ONE Intelligence today. So there needs to be some level of API integration that like both the products will have to kind of agree upon, and so that like the context and stuff can be derived from like a third-party product.
So to get the full experience, you gotta, if you have something, you gotta migrate.
Yeah.
Okay.
So obviously, I kind of summarized, but the key takeaways are with our SASE POPs, right? So it's with our SASE itself, right? I mean, some of the things that I think Craig kind of talked about is we are building services within SASE POPs, and then also we are working closely with like other vendors, like for example, Zscaler and stuff, to better our integrations, right? So the idea is we want to have customers, we want to give the flexibility to the customers where we have like a single integrated solution that they can use, or if they want to actually use a third-party vendor, so we still continue to actually integrate with them, right? And with our gateways, right? So obviously we always shoot for how we can actually scale our gateways, have have better resiliency and have actually a better scaling capacity of the gateway, and then also like also have like a global presence, right? So obviously we are working on like upgrading our POPs to support this cloud native architecture. And like as the newer evolutions come by, right? So we'll kind of actually tend to refine our architecture and evolve our architecture around that. So these are the key takeaways that I wanted to just go through, just understand, hey, what the VMware Secure Access Service is, and then it's not just bringing in of two different technologies together, but like how we have evolved our POPs to actually kind of host them efficiently, and then offer like an effective solution or a service to our customers. So by doing that, I'm going to just do a quick demo walkthrough of the VMware Secure Access. So just to give a little bit of a preface to how the demo topology is set up. So the VMware Secure Access, that's the VMware Secure Access service is actually running in a POP, and I have a Workspace ONE device which is managed. It's connected to the nearest POP. So what we do is like based on the obviously this is the demos. That's the reason I have a single POP. When there are multiple POPs, right? We look at the geolocation of the IP of the user which is coming in, and then we try and connect the user, or we connect the user to the nearest POP, right? So from the flow perspective, I just want to point out that the same thing has happened here. Let's assume that there are multiple POPs, and this is the closest POP to the user. So it connects to the closest POP. And the user device is actually an iPad. It's registered with Workspace ONE. And I have some policies configured on Workspace ONE traffic rules, or the traffic policies configured on Workspace ONE. So with Workspace ONE, you can control what applications the users coming from the device can actually go to or have access to. And also, the other thing with Workspace ONE access is it's a per app based TLS VPN tunnel, right? Based on the applications that you're configured, only those applications are going to be tunneled through the TLS tunnel, which is formed. So I'm bringing the SD-WAN component also in together here. So in the VMware Secure Access POP, there is the gateway, and then it connects to the data center on the right side. So when there is traffic which is destined to the internal data center, right, it's actually sent. It is actually sent to the SD-WAN component sitting next to the we call it the tunnel server, which terminates the client TLS connection. And it's carried on a secure tunnel from that POP to the data center, to the enterprise data center where the application is hosted. So in this example, I just have like a very quirky Apache server running behind Edge, which is actually acting as a data center. It's called internalapp1.com. And what I'm doing is I'm just actually letting the user access VMware.com and YouTube.com. So we don't have the Cloud Web Security component yet, but when the Cloud Web Security component comes in, so the admin will have more flexibility in terms of configuring like the categories, like URL categories and stuff, to become more granular with respect to what they want to allow going to the internet and stuff, right? And then in the same device traffic rules, I have the internal app1.com, that's the application like which the user is actually allowed to access, right? So just kind of move a little forward. I'm going to actually walk through the UEM console. This is the UEM console where all the Workspace ONE configuration happens. So on the top, it just says that, hey, this is the UEM server which I'm using for this demo. And like when we jump onto the device actually registers with this UEM server and gets all the information to which, like the tunnel service it needs to connect to in the SASE POP, right? So here, all I'm going to is that's a dashboard which showed that, hey, the user is actually registered, and here are my two devices which are connected to this tenant. So the first one, the test global iPad iOS, That's the one that we're going to look at. That's the registered device. I have another Android device registered to this UEM as well. So now we're going to go to the device traffic rules that I talked about, where I allow VMware.com, YouTube.com, and then the internal app1.com. And then I have certain block policies also set for certain destinations so that the user doesn't access. So we'll actually quickly try that too, just to make sure that it's working. So when I talked about, hey, the user based on the GeoIP connects to the closest location. So all the SASE POPs for a particular tenant, for a particular customers, they all are actually hosted and then they're referenced to a single FQDN, right? This is the FQDN here. And what happens is once the UEM, once the device registers with the UEM, this is the FQDN which is sent to the device. And then when the device tries to resolve the IP address for this FQDN, that's where the closest GeoIP location will come into play. It just says that the port 8443 is being used to connect the TLS tunnel. So there are two options, like either 443 or port 8443 can be used. I'm using 8443. So like I said, this is the managed device. So I have the flexibility of choosing what source application that from where the traffic is coming that I want to actually batch. So I have Safari iOS, which is actually installed on my iPad. So all the traffic that is going to the web is coming from Safari iOS. And then I have an action of tunnel, which says that, hey, tunnel all this traffic. The traffic actually is the destination which I've mentioned. So VMware, YouTube, CNN, and then the internal app1.com is the internal application. And then I'm saying that, hey, if the traffic goes to CNBC or Facebook.com, please do block it, right? So these are the device traffic rules. This is my iPad. And if you look at my iPad, there are two apps. One is the Intelligent Hub app on the left, and then there is a tunnel app. The Intelligent Hub app is the one which does the registration, downloads the profile. There are, like, given this is a managed, there are actually two profiles. One is the device level profile, and the other one is the VPN profile to actually make the TLS connection to the tunnel container. The tunnel app is just to actually kind of give user the information saying that, hey, whether the tunnel is connected or if there are any problems, so that the user, like if he has any issues, he can actually do some basic validation and then go back to the respective IT teams, right? So once we click on the hub, you can see that the device is already enrolled with that secure access service. So do remember I talked about the UEM, so it's actually registered to that UEM. And the group ID is the tenant, the global corp which I mentioned. And then the username is actually the user who's actually accessing this device. So I had defined the usernames there in the UEM console when I showed before, right? So that's about the hub, and then we'll jump to the tunnel app. So here is the tunnel app. It says that, hey, device VPN configuration is configured. It's connected to the internet, and then the enterprise network is, hey, it has VPN successfully established with the nearest tunnel service, right? Now I go to like CNBC.com, and it should be blocked because I have a block policy. You can see that the traffic is not able to reach CNBC.com. So I allowed YouTube. I'm just actually I'm going to actually click on a video here, and then I'm going to actually let some traffic run, right, so that we can see some traffic statistics and stuff, right? So I'm going to jump forward. This is actually just a video running. So once the YouTube, it went through, and then now what I do is I'm going to just go to like my internal application, right, internalapp1.com, which is hosted in my data center. So like I said, it's not a fancy UI, just a quirky application. So you can see that like I can reach the internal application. Obviously, without the device being enrolled with Workspace ONE, or neither having, if we didn't have the tunnel application, right? So the user wouldn't have the remote access or access into the enterprise application. So this is pretty much on the demo part. This was a quick and then a small demo. I'm pretty sure next time we'll have like more and more services that we can show from our SASE POP.
So on a managed device, if it loses the connection to the POP, can you have it set where all network connectivity for the device is killed until that tunnel is reestablished?
You mean like all the existing sessions which are going on the device, will it be killed when it actually reestablishes?
Well, no.
Yeah.
Have it where, say, a secure device that is doing PCI or HIPAA transactions, they lose connection to the tunnel. Can you have it set where until that tunnel is reestablished, no traffic is allowed to leave that device or go to that device?
Okay. I'm not a Workspace ONE expert. I'm going to defer that to Andriano. He's from our Workspace ONE BU. Andriano, like, is that something which falls in your alley?
Yeah, so you're saying if we lost the connectivity via tunnel, you want to block all the external connectivity from that device?
Correct.
No, because the concept of the tunnel is PerApp Terminal, okay? We are basically, this is not like the traditional VPN that you are fully trafficking the full device through a gateway, right? In this case here, you are specifying what are the apps and what are the domains those apps can access. So if you have other apps on your device that are not configured to perform PerApp Terminal, they will be trafficking through your internet gateway outside of the POP. Okay. So basically, when we define a configuration for one application to go to a specific domain, all the traffic is going through that tunnel app that goes on the device. And that tunnel app is validating the device, validating also the user on that device. And when that connection gets into the gateway in secure access, we are checking if that device is in compliance. There is a number of roles that you can define on Workspace ONE to define if the device goes out of compliance. If the device goes out of compliance, that traffic will be terminated on the POP. It will not be initiated actually on the device, but in some reason, if the device gets out of compliance between that time frame, we are going to be terminating the traffic on the POP, and that will not hit your internal network. There are multiple steps of security, device, gateway, until we get to the final destination. So basically, when you look across zero trust, right, we need to have these multiple checkpoints to check the device, the users, and that's what we are basically doing with Workspace ONE Tunnel here.
Okay. I would think that there'd be people that out there in highly regulated environments that would say, okay, if I can't have it where all traffic ends when the tunnel goes down, it's a dead end on the solution, because at that point, you're potentially sending sensitive data over the open internet. No,
you are not, because the fact is, when you said that your credit card information that goes into a specific app, go to a specific domain, and the network connectivity goes down, that traffic is tunneling through the tunnel app. The tunnel app detects that, and you will not send the traffic any other place. It will remain on the tunnel app. Okay, there is no other place to send that traffic except through that tunnel app, because you define that security policy. If there is no network connectivity, the traffic is not going anywhere. Period.
Okay. And another point is for the our POPs, like we focus on resiliency within the POPs and across the POPs as well, right? So even if there is actually at some point where, hey, like we lose connectivity to a particular POP and stuff, right? So given there are like other POPs within the same tenant, right? So the service, the secure access service for the same tenant in the other POP should be able to connect to the same device and stuff, right? Within the POP also, what we do is with Cloud Native, if a container which is serving that particular device traffic, so it has some issue, then we automatically scale up and then bring another container online to actually service it.
Yeah, but you're always going to have issues on the client side, Wi-Fi going out, AT&T, Verizon, whoever having dead zones. So while your side of the service may be resilient, there's always going to be client side issues.
Yes, and that's why the reason we have Workspace ONE again, right? So we have the ability to manage those devices. And for example, from the mobile perspective, right? We are enforcing encryption on those devices, right? When we enforce encryption, the data that's coming with the application, it's getting encrypted as well. You can leverage Workspace ONE SDK to leverage the same capabilities that we have today in terms of secure certificate binding and so on into your application as well. Another thing that is important here that I didn't mention is at the moment we start managing the device with Workspace ONE, that device gets a unique certificate that's managed by Workspace ONE, and that's how we make the authentication against secure access. So that TLS traffic, it's only the tunnel app and the tunnel service on secure access, they establish trust because they have that unique certificate. So nobody else can actually will be able to hit that that communication. And there are two ways also that I want to emphasize here. We have the concept of fully managed device, where it's more applicable for the corporate device, right? You want to push profiles, you want to restrict, change settings on the device. You want to have more control of the device because it's a corporate one. And we have the support as well for what we call register mode, which is more for the personal use case, right? You have your personal device, but I will not be able to be so invasive and change all the security settings on your device, right? So I cannot do it because it's your personal. We are able to allow you to use the tunnel with these two modes, right? From the fully managed or just managed, partially managed for BIOD use cases. So that allows us to leverage pretty much the same levels of security that we have on the tunnel and allow the traffic to go through the corporate network in a much more secure way instead of being invasive on the personal device and things like that. So I think it's important to mention this.